Sampling parameter and statistic. A population is the entire group that you want to draw conclusions about. To study a population, it is ideal to get data from each member of the population. So this is the population. We concentrate on the data gathering procedure to a subset or part of the population. This subset is the representative of the population and known as the sample. So this is what we call the sample taken from the population. And this must represent the population. Now, a sample is the specific group that you will collect data from. The size of the sample is always less than the total size of the population. The sample should be chosen well so that it will correctly reflect the characteristic of the population where it was taken. Sloven's formula is used to calculate the sample size necessary to achieve a certain confidence interval when sampling a population. Confidence interval. So in this case, we have here N be the population size and the margin of error E. This is the counterpart of confidence interval. So the total of that is 100. If the confidence interval is 95, margin of error is 5%. And this one, margin of error, denotes the allowed probability of committing an error in selecting a small representative of the population. So the sample size N, the formula is this, can be obtained by the formula. Sample size N is equal to the number of, or the population size N, capital letter N, 1 plus population size, margin of error squared. So that's how you compute for Sloven's formula. Again, the confidence interval, if the confidence interval or confidence level is 95%, the margin of error is 5%. So the total must be 100. If the confidence level is 90, then your margin of error is 10%. There are several different sampling techniques available, and they can be subdivided into two groups: probability sampling and non-probability sampling. In probability sampling or random sampling, you start with a complete sampling frame of all eligible individuals from which you select your sample. In this way, all eligible individuals have a chance of being chosen for the sample, and you will be more able to generalize the results from your study. So that is for the random sampling. Probability sampling methods tend to be more time consuming and expensive than non-probability sampling. In non-probability sampling, you do not start with a complete sampling frame. So some individuals have no chance of being selected. Consequently, you cannot estimate the effect of sampling error, and there is a significant risk of ending up with a non-representative sample which produces non-generalizable results. However, non-probability sampling methods tend to be cheaper and more convenient, and they are useful for exploratory research and hypothesis generation. Now let's talk about the methods of probability sampling. Number one, simple random sampling. In this case, each individual is chosen entirely by chance, and each member of the population has an equal chance or probability of being selected. Example, the names of 25 employees being chosen out of a fishbowl from a company of 250 employees. In this case, the population is all 250 employees, and the sample is random because each employee has an equal chance of being chosen. Number two, systematic sampling. Individuals are selected at regular intervals from the sampling frame. The intervals are chosen to ensure an adequate sample size. Example, from a list containing the names of 500 members of an alumni association, a sample of size 50 is obtained by including every 10th person in the list. So there is a system. Every 10th person in the list. It can also be every 5th person, every 2nd person, and so on. Number 3, stratified sampling. In this method, the population is first divided into subgroups called strata, who all share a similar characteristic. It is used when we might reasonably expect the measurement of interest to vary between the different subgroups, and we want to ensure representation from all the groups. Example, the students in a given school are classified according to year level. Year level. So these year levels are called strata or subgroups. Now 20 students from each strata or each group or each section will be randomly chosen to participate in a study involving students. So all groups are included here in stratified sampling. Number 4, clustered sampling. The elements of the population are divided into groups called clusters. To obtain a sample, clusters are selected from the set of all clusters randomly, and all the elements from the chosen clusters are combined to form a sample. Example, among 25 sections in a school, so the sections are called clusters. 10 sections are chosen randomly. So 10 sections only are chosen randomly. All students who belong to the chosen 10 sections will participate in a study. So not all sections are included in clustered sampling. Unlike stratified, all sections are included. Now let's proceed to non-probability sampling methods. Number 1, convenience sampling. This is perhaps the easiest method of sampling because participants are selected based on availability and willingness to take part. Number 2, quota sampling. This method of sampling is often used by market researchers. Interviewers are given a quota of subjects of a specified type to attempt to recruit. Number 3, judgment sampling, also known as selective or subjective sampling. This technique relies on the judgment of the researcher when choosing who to ask to participate. Researchers may implicitly thus choose a representative sample to suit their needs or specifically approach individuals with certain characteristics. This approach is often used by the media when canvassing the public for opinions and in qualitative research. Last method is snowball sampling. This method is commonly used in social sciences when investigating hard to reach groups. Existing subjects are asked to nominate further subjects known to them. So the sample increases in size like a rolling snowball. So that's an example of non-probability sampling method. Now, when a sample has been selected, summary measures are computed using the data gathered from this sample. These measures are called statistics. In short, a statistic is a measure taken from the sample. Examples are sample mean. So this sample mean is an example of a statistic, sample variance, and sample standard deviation. Now, for the parameter is a measure taken from the population. Examples are population mean, population variance, and population standard deviation. Again, for statistic Statistic is a measure taken from the sample. Parameter is a measure taken from the population.